Hello, everyone. We're calling this experiment Exploration with Static Electricity. We have a standard involved, and the standard is to investigate and describe types of forces, including contact forces and forces acting at a distance, such as electrical, magnetic, and gravitational. So obviously we're experimenting with the static electricity portion of that. All you need is balloons, an empty can, and perhaps some water to kind of throw variables in there. So to begin, I need my partner.
Oh, yep.
So I begin by asking my partner to hypothesize and say, so Liza, what do you think is going to happen if you rub the balloon on the carpet or someone's hair and put it towards the can?
I think that the can will attract to the balloon, and the can will roll towards the balloon.
Cool.
All right,
Let's give it a shot.
You think like 30 seconds is enough?
Yep. So we are now rubbing the balloon on the carpet.
All right, let's try it.
I see movement.
A little bit.
Okay.
I wonder if it'll move less with less balloon.
All right. Well, then let's try with a smaller balloon. Let's remove this random person's piece of hair. And smaller balloon, experiment number 2. More gross hair. Okay, so let's check it out.
Oh, it's like nothing fan. A little bit.
Oh, the tiniest. There we go.
Yeah, the tiniest bit, but not like the first one.
No, you kind of have to like.
Oh, that's
wait,
cool.
there we go.
Now are you touching the balloon too?
I'm not touching the balloon. I'm getting really close, but I'm moving the balloon like around to provide more like surface area that was on the carpet. So I feel like it's almost the same.
Yeah, I guess so.
So I guess it's not the size of the balloon, but like where, like how
You
much of it
position it.
is. Yeah. Cool.
That is pretty cool.
Now, what do you think will happen if we add water to the can to provide some weight?
It'll probably like make the can not move at all because, I mean, depending how much water you add, it'll probably eventually just hold down the can completely.
I agree.
Okay, let's try it.
Let's try.
So this is just 1 cup and we're just going to add a few drops. It's going to be so messy, I feel like.
That's all right. This is in our room.
Okay, let's just try with that much.
That works. That's all right. It can spill.
Okay. All right. You want to do the big balloon or the small?
Yeah, we'll do the original balloon first.
Let's try it. Ready?
Mm-hmm.
Oh, wait, a little bit.
Like the slightest movement.
Yeah.
So even just the most minute amount of water added affects the way the can rolls. It's barely even moving at all.
Yeah. I don't want to turn it. Come. Do you want to try to add more? See if we can hold it down?
Sure. We can add a little bit more, and then it probably won't move at all. That's what I'm guessing.
Yeah.
That would be my hypothesis.
All right, so we're about 1/2 cup of water now.
Okay. Let's try it with the smaller balloon just to see
Okay.
if that matters. getting like no movement at all. Nope.
All
Nothing.
right.
So half a cup of water the can doesn't move at all. Obviously, it's just because it's heavier.
Yeah. So then we would basically just talk to the students and have them hypothesize just like we did, and then go through why they thought the can moved in the static electricity.
Right.
Right?
So we could use this as an engagement exercise to get them interested, and then they can they can do it themselves to explore, and then we can go into further detail and explanation, talk about how the balloons are charged with negative electrons, and the can has positive, and they opposites attract, so it does pull the can.
Right.
And I'd say that concludes our experiment.